Finding the domain and range of a function. In this video, we'll talk about some common restricted values for the domains of functions, describe the domain and range of a function when it's given as either an equation or a graph. If you have a nut shelling machine, the input is cashews in the shell, the output is cashews out of the shell. What if you drop a rock in the machine? It's not a cashew. It can't be shelled. It might break the machine. Suppose we have a function f of x equals 1 over x. The input set, or the domain for this function, should come from all the real numbers. But if I put 0 in for x, I get 1 over 0, which is undefined. 0 acts like a rock in the machine, and the domain of this function cannot include 0. So the domain of this set is any real number except for the number 0. So basically we say that if we put a number into a function and we don't get a number out, we can't include the number in the domain. And there's two kinds of functions where that often happens. Those two types of functions are rational functions, where there's a x in the denominator. The denominator can't be 0. And the other kind is a square root function, because inside the square root can't be negative. If I want to find the domain of this rational function, f of x equals 3x divided by x minus 2, I need to look at the denominator. The denominator cannot be 0. So x minus 2 cannot equal 0, and I can solve that just like an equation by adding 2 to each side. X cannot equal 2. We would call 2 an excluded value. It's being left out of the domain. So the domain is all real numbers except for 2. If I find the domain of f of x equals the square root of 7 minus x, I remember that the part inside the square root cannot be negative. So 7 minus x has to be greater than or equal to 0. And if I solve that inequality, I add x to each side, then I have 7 is greater than or equal to x. We can flip that around and say that x has to be, see the pointy end is pointing towards x? X has to be less than or equal to 7. That means on the number line, I'm interested in numbers below 7 because they'll make the inside of this square root positive. Numbers above 7 will not, so they have to be excluded from the domain. So the domain would be the set of all x in the real numbers such that x is less than or equal to 7. Sometimes it's important to find the domain and the range of a function. Here's a graph of a function x squared minus 1. Now if I think about the domain, it's not a rational function or a square root function. Any x at all will work. So the domain, which is on the x-axis, is any x. All real numbers are in the domain. But the range isn't all real numbers because the parabola here never goes below -1. -1 is the least number, and only outputs above -1 will happen no matter what input you put for x. So the range of this is that y has to be greater than or equal to -1. So notice that I'm using x for the domain, x is any real number, and y, the range, has to be greater than or equal to -1. I can never get -3 as the result if I'm solving the equation x squared minus 1, because I'll have -2 equals x squared, and x squared can't be negative if it's a real number. For our last example, we don't have an equation at all. We have the graph of something that's a function. If I try the vertical line test, I don't get 2y's for any of the x's. But it's kind of artificial in that it's limited. It's limited in both its domain and its range. So its domain goes between -4 and 6 on the x-axis. The open circle means that -4 is not included. So the domain is this interval from -4, not including -4, up to 6, and including 6 because I have a solid circle there. I can't put -5 into the function and find an output because the graph doesn't go there. So I don't know what value it might be. It doesn't exist as a value. Well, how about the range? Well, the lowest point on the graph here seems to be almost to -2, but not quite, and the highest point on the graph goes up to 2. Remember, the range is along the y-axis. So it looks like what we have here is an interval. It does not include -2, but it goes right up to it, and it does include +2. So the range is an interval from -2 to +2. But remember, it's on the y-axis. So that's how you look at a graph and determine the domain and range.